Hello again, algebra students. Today we're going to continue on with solving inequality or working with inequalities. Yesterday we were just talking about writing inequalities and graphing inequalities. Now we're going to be solving inequalities, and today we're just going to focus on solving them using addition and subtraction. So if I gave you a problem like this, if this was just an equal sign, we would know exactly how to solve it. The nice thing is we're going to solve this exactly the same way we would as if it was an equation, if it had an equal sign in it. So I would say I want to get the x by itself, so I would want to add 6 to both sides. So there's my x. Instead of an equal sign, I do have my inequality, greater than or equal to, and negative 10 plus 6 is going to be negative 4. Now, that's nice, but really the final answer in an inequality is the graph, because that's going to show us where all of our solutions are. On the last lesson, I said I would show you what I really expected from graphs. And here's the thing, I don't need a huge number line. I want 3 numbers. I want to see where my important number is, which happens to be negative 4. And then I need a number on each side. Keep in mind, if we're dealing with negative numbers, think about where 0 would be. 0 would be over here somewhere. So this is going to be a negative 3. As we're moving backwards, we're getting to negative 3 and then negative 4 and then negative 5. At negative 4, because this does have an equal, a half of an equal sign right here, that is going to be a filled in circle. And because it's greater than, these are the numbers that are greater than negative 4. So if you don't have a number line provided for you, please don't make a huge one. You really just need to have 3 numbers on each number line. This problem is very similar. When I'm solving this, I want to get rid of the subtracting 5 so I can get the x by itself. So I would have to add 5. And I'll have x is now less than 2. The only reason I did this extra example just like this is because now I want to be able to talk about the fact that this is not a half of an equal sign. It's going to be an open circle because x is not equal to 2. Here's our 2. So I'd have 1, 2, and 3 on my number line. This is going to be an open circle. And then because it's a less than, it's going to shade to the left. And again, remember, this is pointing to the left, and so is the arrow. As long as the variable's first, you can follow that rule. I don't think we need to do all 3 of these problems. I want to take a look at number 3, though, because there's something special about it. Not the fact that there's fractions, but there's something else. The fact that the variable is on the right-hand side is the part that's important, because in the last problem, I just said I have to have the variable first, but it's not first. First, let's get the y by itself, and then we'll flip things around. So to get rid of subtracting 1/4, I would add 1/4. 1/4 plus 1/4 would be 2/4, but that does simplify to be 1/2. So I'm going to have 1/2 is greater than y. But, and I showed you one like this yesterday, I need the variable first. So I would have to write this as y is less than 1/2. Now, notice the alligator is trying to eat the 1/2 in both of them. That means I did it right. It does say to graph this solution. Now, instead of counting by halves on my number line, remember I said I needed 3 numbers? Sometimes when it's a nice one like a 1/2, well, I would say here's 0 and here's 1. So a half would be here. Make sure you label it though. And this is going to be an open circle because it's not equal to 1/2, and it says less than. So we're heading off to the left. Again, we've got a left arrow on both of those. These problems now have some addition instead of starting with subtraction problems. So for letter A, I would start by wanting to get rid of the adding 8. So I would subtract 8 on both sides. And I'll get that y is less than or equal to, you can do a keep change here if you need to, a negative 3. So again, here's my negative 3, that's my important number. One number bigger, to the right is bigger, would be negative 2, and one number smaller would be negative 4. Because I do have that half of an equal sign, that's going to be a filled in circle, and a less than goes to the left. Arrow points to the left on both. On number or letter B, again, the variable's on the right-hand side, so we have to be careful about that. I want to get rid of adding the 1.4, so I would subtract 1.4. There's my M, that's what I wanted. There's my inequality. If you want to change that to keep, change, please do so. Feel free to use a calculator if you want to, but remember this is really negative 8.0. So when I have those two negatives, they're the same signs, I'm going to add, that's going to be a negative 9.4. I want the variable first, so if I put the variable first and I put the negative 9.4 over here, see how the alligator is trying to eat the M? Still has to be trying to eat the M. Okay, negative 9.4. Again, you can go with negative 9.3, negative 9.4, negative 9.5. Perfectly fine. Personally, I like to go with negative 9 and negative 10, and then realize negative 9.4 is a little bit closer to the negative 9, so maybe about here. It's a little bit off, but that's okay. Not equal, so open circle, and then I'm going to the right because I want numbers that are greater than. Again, I don't think that we need to do all three of these. Number 5, again, because of the fraction, I know fractions are our friends. Let's take a look at this. So I would subtract the 1/6. When I do that, 5/6 minus 1/6, same denominator, that's nice. So I'm going to have 4/6. First issue is that the z isn't first. So I want the z first. And notice that the alligator is trying to eat the z. 4/6 though, that's the other issue. I wouldn't leave that. I would divide both of those by 2 and simplify to get 2/3. Now when you graph this, 2/3 would be between 0 and 1. And 2/3 would be about here. I'm sorry about the red thing right there from my pen. There's 2/3. That'll be a filled in circle because it's equal, and greater than goes to the right. Number 6, I guess we'll still do that one just quickly. The fact that it's a decimal and we haven't seen a lot of decimals lately, let's subtract 0.7. I would even do a keep, change so you can see that those are the same signs. P is greater than, they're both negative, so it's going to be a negative. When I add those together, get -3, which makes it a little nicer for the graphing. It's an open circle because it's not equal, and we're going to the right. All right, this one, I know there's a lot of reading on this, but some houses that don't have a real good electric system, you can like pop your circuits, or you have to flip your circuit breakers depending on what kind of thing you have. So this particular circuit overloads at 1800 watts. That means that if you use 1800 or more, it's going to blow the circuit. Okay, so you're using a microwave and that uses 1100 watts. That's already plugged into the circuit. I want to write an inequality that shows how many more watts I can use. What I'm looking for here, the additional watts that I can use, and I have all of this information here too, that's this. I want to find how many more watts I can use. So the microwave uses 1100. I want to figure out how many more watts I can use, and it has to stay under 1800. By the way, I have no doubt that you can just do this in your head and you know this, but we're using easier problems to practice so that you can practice writing that. So when we solve this, let me just get rid of that shade. I'm going to see that, well, you can almost see it, but the screen is covered right now. W is going to be less than 700. So then my next question is, out of these different appliances that are up here, I want to know what else I could still use and not overload my circuit. Well, as long as it's under 700, that'll work. So clock radio, that's only 50, that one's fine. Blender, 300, that one's okay. Hot plate, nope, that's too much. And the toaster is too much. Now we're shopping. It says the shirt that you want to buy costs $15.50. You can use a $5 discount coupon if you spend at least $20. And there are some stores that will do that and say, if you spend at least this much, you can use this coupon. So I want to figure out how much more I have to spend. And again, I know that you can do this in your head, but we're practicing writing the inequalities. And I'll tell you, the $5 discount, please don't try to use that in your problem. The $5 is not going to go into our inequality. You are spending $15.50 on this shirt that you love and you have to have. You want to spend some more money so that you can get to be at least $20. Right? If you can use a $5 coupon and you spent $20, well, that brings it down to $15. That means you get your shirt for less than the price and you get some more stuff. So I want this to be at least, means it has to be $20 or more, greater than or equal to 20. Okay, when I solve this, and feel free to use a calculator if you'd like, that's going to be $4.50. So that means if you can find something that costs $4.50 or more, you'd hit your 20 bucks, and then you can use your coupon and you get more stuff for less money. Here's the last part of this. It says write and solve an inequality that represents the numbers that are not solutions for this. So for this first one, I'm saying that S plus 18 is greater than or equal to 21. You have two options here. Either you can solve this one and then get the opposite of that answer, or I could just change the original problem and solve that one. A lot of times I like to just solve this the way that it looks right now. So I would just subtract my 18. So S is greater than or equal to 3. That means that 3 or more is my solution. Anything that's 3 or bigger works. But here's the thing. I want to know the things that are not my solutions. So I need to keep the S. So for not solution, I would want to keep the S. I would want to keep the 3. But I need exactly the opposite sign. Here's the thing. It's not going to be less than or equal to, because the equal part is part of the solution. So all I want to do is get the exact opposite sign, which is a less than. Anything that's less than 3 is not the solution for this. Okay, so let's take a look at one more. Here's my original problem. It says that negative 5.2 is greater than x plus 2. So again, we've got a little bit of an issue that the x is on the right-hand side, but I would want to start by subtracting 2 and do a cube change if you need to. Negative 7.2 is greater than x, so x is less than negative 7.2. Those are my solutions. Everything that's less than negative 7.2 would be a solution. So if I want the things that are not a solution, I would want to keep the x. I would want to keep the negative 7.2. But remember now, negative 7.2 is not equal to in this problem. So I know that in the opposite, I will need the equal. And this was a less than, so I would just need to switch it to a greater than. Again, it's just using the exact opposite symbol. Today, your homework or your practice is worksheet 2.2. When you finish that, first of all, make sure that you show your work. Make sure that you're doing the graphs if they're asking you to graph. Then make sure that you finish up the formative quiz in Schoology. I know I didn't write that on here, I'm sorry, but you know that there's going to be a formative quiz after you finish up your practice problems. If you need any help, let me know.